So in this video we'll be going through how to work with short and long division using the bus stop method. So one of the most common, quick and efficient ways of doing division without the use of a calculator is by using what we call the bus stop method. This method works when you're dividing by a whole single or double digit number. So basically what that means is when we can't use the bus stop method when you are dividing by a decimal number. Now, to be able to divide, you must be comfortable with multiplication and subtraction, either mentally or by writing it down. So what that basically means is you want to be competent at your times tables up to 12, but also being able to write down the 14 times table or the 23 times table, which will obviously help when you're doing long division. So let's have a look at the next. So in terms of setting up the bus stop, now this is again where it can all go horribly wrong. So you want to make sure that you're using the right components of your calculation of your division or the fraction to be able to set up your bus stop correctly. So it's really important to know when you're looking at division questions which number goes inside and which number goes outside the bus stop. So if your question is written using the division symbol, then basically the first number is what goes inside and the second number is what goes outside. And if your division question is written as a fraction, then the numerator or the top number goes inside and the bottom number or the denominator goes along the goes on the outside of the bus stop. And so what we're looking at here is we've got our numerator goes inside and our denominator goes outside. And likewise, if we've got the top number and we've got the bottom number and whatever word that says, let me just correct that. There we go. And so it's really important that you make sure you understand which order the sort of parts go inside and outside the bus stop. So the best way to kind of go through this, let's have a look at the following questions. So what comes in handy is knowledge of the up to the 12 times table. So I've got a grid there that we can reference when we're working through this. So if you look through these questions now, if you wanted to have a go at these questions, by all means just pause the video and have a go at the questions yourselves, but I'm going to go through the next sort of 8 questions and that we've got on the screen. So let's have a look. So the first one here we've got is 4. So 4 goes outside the bus stop, and I'm going to write down 1, 2, 4, 8. Now one thing I would recommend that you do is try and focus on presentation. So try and space out the numbers or the digits inside the bus stop, quite spread them out, because obviously we're going to have some little numbers that go inside. Now what I'm going to be saying is basically what you should be thinking. So let's first of all get a different colour. Let's go for a blue. So the first thing we'll look at is think to yourself, how many 4s go into this first digit? So how many 4s go into 1? Well, that's going to be 0. And then what you then do is you carry whatever number you've not used or whatever remainder is over to the next number. So I've got a remainder of 1, so the 1 goes over. Now what that then becomes is 12. So what I then want to do is ask myself, how many 4s go into 12? So I go along my 4 times table, which is here, and I can see that 12 is here, so it then becomes the answer is 3. How many 4s go into 4? That's going to be 1. How many 4s go into 8? And that's going to be 2. So your final answer is going to be 312. And where your answer is, it's basically whatever number is along the top. So this here will be your answer. And there you go. And then what you want to do is not leave it on top of the bus stop. You want to write it out again and obviously underline it just so you can see what the actual answer is. So let's have a look at question 2. Let me get a different colour on that one. What's going on? Right, so with regards to question 2, so again we've got 6 goes outside, I set up my bus stop and I've got 3, 2, 8, 2. So again I'm going to ask myself how many 6s go into 3, so that's none, and I carry the 3 forward. How many 6s go into 32? So again I'm using the 6 times table, and which that's going to be 5, remainder 2, so remainder moves on to the next number. How many 6s go into 28? That's going to be 4, remainder 4, and then finally how many 6s go into 42? That's going to be 7, giving me a final answer of 5, 4, 7. And then with question 3, here we've got 7 goes outside the bus stop. I've got 6, 8, 6. So again, I'm going to be using the 7 times table. And so how many 7s go into 6? 0. Carry the 6. How many 7s go into 68? So again, I'm going to look for there. So it's going to be 9. And I'm going to do 68, take away 63, which gives me 5. And then how many 7s go into 56? That's going to be 8. So the answer there is 98. Now, in the next 4 questions, all we've got to do is we've got to find out what the remainder is. So again, I'm going to kind of use this same method. So let's first of all just get rid of all of this so we've got a bit more space. Now, I've purposely picked probably the most unfavourable times tables when working through this, just so we can get some practice of this. So looking at these questions, so number 1, we've got 9 goes outside the bus stop, and we've got 5, 6, 8, 3. So again, how many 9s go into 5? 0, so I'll carry the 5. How many 9s go into 56? That's going to be 6, remainder 2. How many 9s go into 28? That's going to be 3, remainder 1. And then how many 9s go into 13? That's going to be 1, and the remainder is 4. So my final answer for this particular question is 4, because the question is asking me to find the remainder, not the division. For question 2, again, we've got 3 goes outside the bus stop. I've got 7, 8, 9, 5. And so here, how many 3s go into 7? Let's get a colour pen. That's going to be 2, remainder 1. How many 3s go into 18? That's going to be 6. How many 3s go into 9? That's going to be 3, no remainder. And how many 3s go into 5? That's going to be 1, with a remainder of 2. And moving on to the next one, so this is where we kind of move on to a slightly more advanced level where we're going to write the actual decimal. Now for this, we're not going to write the remainder. Now this is probably what you're expected, probably more at GCSE, but also at high level Key Stage 3 as well. So here we've got 8 goes outside the bus stop, and we've got 3, 8, 6. So here, how many 8s go into 3? Well, that's going to be none, carry the 3. How many 8s go into 38? That's going to be 4, remainder 6. How many 8s go into 66? That's going to be 8. Now, rather than writing r equals 2, what I'm going to do is I'm going to add a decimal point and I'm going to add a 0. So carry the 2. So now that becomes 20. How many 8s go into 20? Let me just rub this out so I've got a bit more space. How many 8s go into 20? That's going to be 2, remainder 4. So every time I've got a remainder, I just keep adding zeros. And then how many 8s go into 40? I've got 5. So the final answer is going to be 48.25. Then for question 2, I've actually just realised I've labelled these wrong. So question 1 that was, and that's for these questions here. And then if I just create a bit of space, and for question 2, now I personally would prefer to, rather than writing remainders, unless the question asks you to find the remainders, I strongly would recommend that you keep going with regards to decimals. So here, let's say we've got 13 over 8, so I've got 8 goes outside and I've got 13. So again, how many 8s go into 1? That's 0. How many 8s go into 13? That's going to be 1, remainder 5. So I carry a decimal point and I add a 0. So how many 8s go into 50? That's going to be 6, remainder 2. How many 8s go into 20? That's going to be 2, remainder 4. How many 8s go into 40? That's going to be 5. And I've got no remainder, so then the final answer is going to be 1.625. And then finally, looking at question 3. Now, again, don't always assume that the bigger number is always what goes inside the bus stop. So for example, if you look at question 3, we've got 7 is going to go outside the bus stop and 2 is going to go inside the bus stop. So again, how many 7s go into 2? That's going to be none. So I add my decimal point and I'm going to carry the 2 because I've not used it. So I've got how many 7s go into 20? That's going to be 2, remainder 6. How many 7s go into 60? That's going to be 8, remainder 4. How many 7s go into 40? That's going to be 5, remainder 5. And I'm going to slowly run out of space. So let me just move. Oh, it's not letting me. Yeah, it is. Move this down. Let me just get rid of all of this. And let's have a look at what happens. So then I'm carrying on. How many 7's going to 50? That's going to be 7, remainder 1. So I add a 0. How many 7's going to 10? That's going to be 1, remainder 3. How many 7's going to 30? That's going to be 4, remainder 2. And then how many 7's go to 20? Now again, you can see I've used 20 before. That comes to 2, remainder 6. And then we've got an 8, remainder 5. Sorry, remainder 4. And what you'll slowly start to spot is that we've got a pattern. We've got a sort of repeated pattern here. So my next number, if you look at here, I've got 0.28571, 4, and then it's 285, and then the next number is going to be 5714, etc. So again, this is a recurring decimal. So how we write the answer to this is 0.285714, and we put a dot where the pattern starts and a dot where the pattern ends, and that there is our final answer. You might find that a question isn't reoccurring and it just goes on and on and on and on forever. So what I'd probably recommend that you do is just write down the first, let's say, 5 or 6 numbers, and then you can just carry on from there. You tend to find that if you do get this question in an exam, they would usually say write this as a decimal, in which it will be a recurring pattern, or the question might say is show that this is a sort of irrational number, which is basically a number that can't be written as a fraction, but then it's going to be, because it's going to be a division, so that then becomes a bit obsolete. So all you want to do is make sure you're reading the questions carefully. If the question's asking for a remainder, then you can just stop and just add the remainder, but typically you're going to be using our third option where you'll be writing as a decimal. So if you have got a remainder, just add a decimal point, then add zeros until it either stops, in which you've got no remainder, or you can spot a pattern. So let's have a look at the next part. So let's have a look at short division, but this time with decimal numbers. Now again, this follows the exact same pattern, which is why we're only going to do 2 examples. So 4 goes outside the bus stop, and we've got 234.672. So again, I'm going to go through the notions. So how many 4's go into 2? That's going to be none, remainder 2. How many 4's go into 23? That's going to be 5, remainder 3. How many 4's go into 34? That's going to be 8, remainder 2. So again, I'm going to add my decimal point. How many 4's go into 26? That's going to be 6, remainder 2. How many 4's go into 27? That's going to be 6 again, remainder 3. And how many 4's go into 32? That's going to be 8, giving me a final answer of 58.668, and there is my final answer. And then finally for question 2, so again here we've got 6 goes outside, and I've got 0.237. So again, going through the notions, how many 6's go into 0? None. So I add the decimal point, I'm carrying on the 6. How many 6's go into, oh, that's going to be a 0 rather, not 6. How many 6's go into 2? That's a 0, carry the 2. How many 6's go into 23? That's going to be 3, remainder 5. How many 6's go into 57 rather? That's going to be 9, remainder 3. So again, add the 0. How many 9's go into 30? That's going to be 5. Give me a final answer of 0.0395. And again, I've stopped because there is no remainder, because obviously I've got 0, 0, and that's it. So there is your 2 final answers. So the next thing we then move on to is our last section, which is looking at long division. Now, so far we've only been dividing by single whole numbers, but what happens if we divide by a bigger number, bigger than 9? So for example, by 12 or 23 or 76. So rather than panicking, there is no need to panic. Well, there's nothing changes. The method is exactly the same. However, what we may need to do is write down the divisors times tables up to 10 to help. So what I mean by that is, if we look at this first example, we've got 8,218 divided by 14. Now what I'm going to do is, for this, is the first thing we want to do is write down the 14 times table up to 10. So from this, and again to do the 14 times table, I would say all we need to do is break this 14 up. So we're going to add 10 and then add 4, and it makes it a lot easier to do that. So 14 plus 10 is 24, plus 4 is 28. 28 plus 10 is 38, plus 4 is 42. 42 plus 10 is 52, plus 4, 56, and so on. So what you would find then is a much easier way of working out the 14 times table. So our next number there is going to be 70, plus 10 add 4 gives me 84. The next number, add 10 plus 4 gives me 98, plus 10 add 4 gives me 112, plus 10 add 4 gives me 126, and then finally we come up to 140. Now unfortunately we're not going to get any marks by writing down the 14 times table, but what it certainly does is it certainly helps you get the correct answer. So now what we're going to do is going to do 14. I'm going to set up our bus stop. So I've got 8, 2, 1, 8, and again I'm spacing the numbers in the bus stop so they're nicely spread, so I'm going to write some numbers in between. So we're going to think, right, how many 14s going to 8? That's going to be 0, and I carry the 8. So now I want to see how many 14s going to 82. Well, look now that I've got the 14 times table written down, I've got 1, 2, 3, 4, 5. So it's going to be 5, and then 70 take away 82 is 12, so I've got 121. So again, I've got 1, 2, 3. How many 14s going to 121? So I've got 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8, remainder, and that's going to be 9. And then finally, how many 14s going to 98? Well, it's going to be 1, 2, 3, 4, 5, 6, 7. So giving me a final answer, and I've got no remainder, so the final answer is 5, 8, 7. So let's have a look at one last example looking at long division. So again, what I'm going to do is I'm going to slowly start by writing the 21 times table. So I've got 21, 42, 63. So again, plus, how I want to do this is plus 20 plus 1. So plus 20 gives me 83, plus 1, 84. And again, going from this, it does take you a bit of time, but again, it's worth it because it just makes the question a whole lot easier. And then just keep adding 20 plus 1, so I've got 126, 147, 168, 189, and then finally 210. So now once I've done that, I can then set up my bus stops. I've got 21 over 9, 6, 0, 1, 2. So again, starting off, how many 21s going to 9? That's going to be none. Carry the 9. How many 21s going to 96? I'm looking at 1, 2, 3, 4. And that's going to give me a remainder of 12. Now again, how I've got 12 is basically by doing 96, take away 84, which gives me 12, and that's where the 12s come from. So then I'm looking at how many 21s going to 120, so that's going to be 1, 2, 3, 4, 5, and that's going to give me a remainder of 15. So then how many 21s going to 151? Well, that's going to be 1, 2, 3, 4, 5, 6, 7, and that's going to give me a remainder of 4. And then how many 21s going to 42? That's going to be 2, and I've got no remainder, so my final answer is 4, 5, 7, 2. Now, division is really, really important that you're able to do. It's one of these life skills that you really need to be able to do. Long division is a little bit of an extension, but again, something that you still expect to be able to do. And you can see that the method is exactly the same. Now, you won't get in an exam or a test, you're not going to get like 15 questions on long division, you'll only get one. And hopefully the big number or the double digit number is not going to be that complex. But what you want to do is be able to break the number up. So for example, if I had, let's say 42, break that up as to 40, so plus 40 and then plus 2. If I had 31, break that up to plus 30, plus 30, and then plus 1. And it just makes it a lot easier for you to write down the times tables to make it easier for you to then work with the bus stop to get your final answer. There are certain different ways of variations of the bus stop. You can actually use what we call the grid method, or by multiplying and then working down. But I personally think that this method is probably going to be a lot quicker, although it may be a little bit confusing and potentially a little bit messy depending on how you present your work. But it's definitely, when you've got your head around it, it will definitely help you and make your life a lot easier. Now there are some questions and some worksheets attached in the description with some answers, so I strongly recommend you practice those. But also what's really good is being a bit smart and checking your answers on your calculator. Now your calculator, obviously if you've typed the numbers in correctly, will be able to give you the actual correct answer, particularly if it's a decimal number, but it's a good way of checking your answers instantly when you are revising, when you are practicing. So I strongly recommend making up your own questions, checking your answers on the calculator, and hopefully, fingers crossed, you get them right.